I'd like to introduce and call up is Eric Tousignant from the City of Ottawa. Eric is a senior water resources engineer with the City of Ottawa. He has more than 25 years of experience in stormwater management, 15 of which were in the private sector. For the past 10 years, Eric has been heavily involved in flood remediation projects ranging from basement flooding in combined sewer areas to overland drainage issues in urban subdivisions. Thank you for joining us, Eric, from Ottawa.
Thank you. Ted, it was nice to see another Paul Wiesner, former Paul Wiesner student here. And anybody else here studied under Paul Wiesner? No, because anybody who's worked with Paul Wiesner will know that you have to learn to imitate him once you've studied with him. And we went to a conference, and anybody who studied with Paul Wiesner, we found ourselves doing imitations of him during the break. It was fantastic. So I'm going to talk to you about flood remediation in the City of Ottawa. And basically, since amalgamation in 2000, we've had about 4 significant events in Ottawa of basement flooding. And September 9, 2004, we were hit by Hurricane Francis that caused over 1,200 incidents of basement flooding. Now, I'm not trying to say this is exciting for a water resource engineer, but because it was such a widespread incident, it gave us a snapshot of how our system performed, and especially the sanitary system. I'll explain later why that's the case. We also had 3 good convection storm events, and those convection storm events have a big impact on the storm system. So also we're able to use those to assess how our system is performing and bring some changes. So we've talked here, you've heard a lot about basement flooding, a lot of you are familiar with this. We have basement flooding due to storm sewer surcharge. The picture on the top is the Orleans flooding in 2006. Basement flooding also due to sanitary sewer surcharge. It comes in through the floor drain and through basement plumbing. We also have overland flooding, which is a serious concern also because during the large rainfall events, the extreme events, there's so much water on the street as the water cannot get into the infrastructure that we don't really see where sometimes it just swamps the roads, and then we start having some cases where cars are underwater, backyards are flooded due to creeks and so on. To give you an idea of the storms I'm talking about, the July 2009 and the June 2002 events you see there are the convection storms that they dropped, I think the July 2009 dropped 140 millimeters of rain in a couple of hours. It was a massive event. And we had, it basically surcharged the storm system. The September 2004 event never reached an intensity greater than a 2-year event. But again, it was 140 millimeters of rain over 24 hours. All that water went into the ground, and it all started contributing to the foundation drains. And in Ottawa, we have a large, partially separated area where the foundation drains go to the sanitary sewer. So imagine all the foundation drains from the entire partially separated area in Ottawa contributing at once to the sanitary system. It's what swamped our system. So just to touch quickly, you've heard earlier about combined, separated, and partially separated. Before 1950, everything in Ottawa was combined. After 1950, they started doing what we call partially separated. They would put a storm system in the street, and that storm system would just capture runoff from the street itself, but the foundation drains were still going to the sanitary system. Then after 1961, we started doing full separation. But a lot of our construction in Ottawa happened between 1950 and 1961, and the combined area, as we were also separating it, we separated to partially separated. So we have quite a large partially separated area. And we can see this on this figure. In the purple is the partially separated area in Ottawa. There's a very small area in the middle, which is, I don't know if I have a mouse here, no, that I can click with, but we have in the middle we have a little combined area. And the beige around the outskirts is the fully separated areas. If you look at all the little dots, the little red dots, those are flooding events from 2004. And you can see that it really hit the partially separated area. So what have we been doing to mitigate this? Well, in the past few years, we've been implementing what we call the Wet Weather Infrastructure Management Plan, or so as I like to call it, the WIMP. And the Wet Weather Infrastructure Management Plan, basically the objectives is flood protection, capacity for growth, and pollution control. So this wet weather management plan, what we're trying to do is put everything under one umbrella. A lot of the work that you see here, flood mitigation, we are doing in the city. But a lot of it's being done piecemeal, more on a reactive basis as opposed to being proactive. So to reach the objectives, we determined that we needed to develop 6 programs. And of those 6 programs, 3 we already have in place. We have a program that's sewer separation, if you look at the far right, pollution prevention control, and operation and maintenance. Those programs are currently underway and they're established, they just need some fine tuning. But the wet weather management plan identified 3 new programs that we need to get going ASAP. And mainly we need a capacity management plan, we need an extraneous flow reduction plan program, and a flood control program. So we're in the process, in the second stage now, of developing these programs. It doesn't mean that we're not doing any of the other work for flood mitigation, it just means now we're going to develop a program where everything's going to fall under one umbrella and we're going to have a strategy that we can take forward to further mitigate floods, help with flood control. We also identify that we need support programs. And again, a lot of the support work we are doing. We do some modeling, we do flow and rainfall monitoring, we do first response. But we're doing it again on a reactive basis, as required basis. Once we have these programs and support programs in place, then we will know, we could prioritize where we need to do work. We could coordinate flood with capacity management, with sewer separation, with extraneous flow removal. All that will be coordinated, and that's where we're heading towards right now. So we're in the process of developing this plan. But I'm going to talk to you about what we're still doing, what we have been doing since the year 2000 to mitigate basement flooding. So our ongoing initiatives. Well, we have the residential plumbing protection program, which I'll speak about in a slide or two. We've brought some changes to our sewer design guidelines. We do have ongoing flood remediation projects. As I've mentioned, unfortunately, most of them are reactive, but we are now actually becoming more proactive. We've identified some areas, and we're going ahead and trying to help. It's just hard. When you go into a neighborhood, and they've flooded. You have 1,200 homes that flooded. And you come in and you say, guess what? We're going to protect your basements, but your streets are going to flood. We're going to keep the water on the surface. Oh, they're happy. They're praising us. Oh, we're gods to them. You go into a neighborhood that never flooded and you say you're going to have water on your driveway every time it rains for 20 minutes. They hate us. They just start yelling at us. So we have to change that mindset. People need to understand what we're doing. We have the real-time control and central storage tunnel project that's underway, which I'll speak about a little later. We ongoing sewer separation, extraneous flow reduction, flow monitoring and modeling, and this last one, public education. Well, the poor gentleman on the bottom, his street just flooded. What's he doing? He's looking for a manhole cover to open, and he is desperately trying to open a manhole cover to drain the street. Worst part is we had emergency personnel helping him at one point. So we really need to get the message out there. That's the last thing you want to do, you know. We're trying to get a message out, better on the street than in your basement. And, you know, yes, your gardens are going to flood. A few garden sheds will be washed away. But it's a lot better than 1,000 flooded basements. So there's a cultural change here in how people think. The residential plumbing protection program, we started that after the 2004 flood, mainly because the majority of the flooding in 2004 was in the partially separated area as a sanitary system backed up. So we identified homes in high-risk areas that had experienced flooding, that they could get a 100% subsidy, up to $5,000, in some cases $7,500, depending on the complexity of the situation, to basically do some plumbing protection, which basically consists of a full-port backwater valve on the sanitary, which, by the way, is in our code now, in our guidelines, that they have to go in. All new development need full-port backwater valve on the sanitary. Includes also putting in a storm, in the bottom picture, a storm backwater valve on the storm line. Disconnecting roof drains. A lot of people flood themselves out without the sewers even backing up. They have their downspouts going right to their storm lateral while they're flooding themselves out when it rains. And sump pumps. And sump pumps, a lot of people, you know, that's a word everybody hates. Nobody wants sump pumps, and my house value is going to go down if there's a sump pump. What I'm trying to explain to people is that sometimes the outlet, where the storm sewer is outletting, could be a river, could be a creek, whatever. It could be surcharged for an extended period of time. If you're in a low-lying area and your backwater valve is closed, it could stay closed for an extended period of time. So what we want is, we basically need something that could drain take the water away from your foundation. And the sump pump is only used in really extreme cases, emergency cases. If your backwater valve stays closed too long, then the sump pump would kick in. It would only be there as an additional measure. But something else we have to explain to people, if we're putting it in their homes in the subsidy program, it's just extra protection. Homes that are in high-risk areas but that have not experienced flooding, they can get a 50% subsidy. So if you're a little nervous because my neighbors in the next neighborhood have flooded, but I just want to also jump onto this program, well, the city will provide this subsidy by 50%. If you're in an area that is not at risk, well, then you're on your own. You'll be the one basically having to do it yourself. Sewer separation. The dark blue line shows you the original combined sewer area in the city of Ottawa. Well, that combined area, that's really was at high risk of flooding all the time. Most of the time it was designed prior to 1950, which meant it had a 2-year capacity. Everything's going into one pipe. It's a direct connection to basements through floor drains, basement plumbing. So we had a push to separate that area, and as you can see, the yellow is showing us areas that still need to be separated or are currently underway. We're in the process of separating those areas. Everything else that's in white has been separated, and the area that's in purple and green, that's what we call the ultimate combined area. And that ultimate combined area, well, we have no choice. We have no outlet. There's no storm outlet. It has to remain combined. And in that area, we're taking other measures. I'll give you an example of one and a little case study later on in Sandy Hill, which is the green area. And we also have the central storage tunnel that's under design right now, which I will also touch on briefly to help mitigate flooding in that area. Dual drainage implementation. Well, basically what we're doing, we like to go into older neighborhoods and we try to convert them to the new standard. The new standard is dual drainage. Dual drainage means you put that little device on top, goes into your storm catch basin. It limits the water that goes into the storm system. By limiting the water that goes into the storm system, you're going to basically make sure that you don't surcharge a storm sewer. And you then manage the water on the surface. In new subdivisions, streets are pretty well designed to run like rivers. So the streets are going to run during big events. They're going to run like rivers. They'll make it to an outlet, to a pond. But in older neighborhoods, the water went where it wanted to go. It'll cut between homes. It'll go anywhere. So we go in, and once we want to implement dual drainage, we try to do overland flow improvements to keep the water on the streets. If it has to go between properties, we'll try to make it safely go between properties. But we want to stop. We do not want the water to touch the buildings. Other interesting aspect is the manhole covers. Look at the bottom, I guess the bottom left. That's a perforated storm cover. And you see those all over the place. But we're putting inlet control devices in the catch basin, but we still have perforated manhole covers. Well, now you have a perforated manhole cover, so when ever see like that picture of the gentleman when he had water up to here? Well, imagine that head of water on top of that perforated cover. That's a lot of water that's going to the storm system. That's bypassing the inlet control devices. We realized that in 2006 when we had a brand new area that we had very little basement flooding, but all the backwater valves, everybody who had them, they heard a loud bang in the basement, so they suddenly shut off. Well, they shouldn't have. That place shouldn't have surcharged. It's just the water was bypassing the catch basins through the manhole cover. The next picture is a sanitary cover, the one in the middle, and that's a perforated. It's another one of our sanitary covers are perforated holes. Again, when you have a lot of water on the street, you can get half to 1 liter per second going through that cover. A lot of covers on the street like that, that's a direct connection to the sanitary system. So we're in the process of replacing those. We don't allow those anymore. The picture on the right shows you the new sanitary cover that we're using. So we don't allow those. And we're replacing the storm covers too. And here is an interesting fact that you'll see often in the street, storm and sanitary covers next to each other. Well, we had a flood in 2009 in the west end of Ottawa, and on two or three occasions we found that both covers were switched by accident. So now you have the perforated cover over the sanitary. Now that's a lot of flow going into the sanitary system, and that will surcharge your sanitary system. So what we're doing, we're putting the new cover on the sanitary and the old sanitary cover on the storm. So if there's an accidental switch, it's not going to be a catastrophic situation. And also we're protecting the sanitary, and we're making sure that we don't bypass the inlet control devices. We just need one cover and we fix two problems. An example of an area that we retrofitted is Orleans in 2006. So the Orleans area, on to the right you have the basins that we studied, and you have the basement flooding pictures on the left. There were 7 basins that we studied. 4 of them were done in-house, 3 through consultant assignments. And there were over 800 incidents of basement flooding. And we also had poor overland drainage in some cases. And most homes did not have backwater valves. So this is homes that were built in the 70s and 60s, and they were separated, but there's no backwater valves. So when the storm system got surcharged, it all went back around the foundation drains and flooded the basements. So the first thing we did is a minor system analysis. We built computer models, and we look at the minor system here. We're seeing that everything's in red and orange is pretty well over capacity. When we're getting to yellow and green, it's getting better. So we study the existing system, and then we run the models again with the inlet control devices in place, and we try to get the hydraulic grade line down below basements. We do this on a manhole by manhole basis. So this is a very complex model. It's not just lump models. We do it street by street, manhole by manhole, and we study the entire basin, and we make sure the hydraulic grade line stays down. Then we have LiDAR data information, which is new in the city, which is very nice to use, and digital elevation models on a 1-meter grid for anybody who's used them. And what we're doing is that it gives us a very detailed overland flow information. With that, we can map out the flooding area, or the surface ponding areas that you see in light blue. We map that in detail, and then we look at what happens once we put inlet control devices in. How worse is it going to get? Do we have an existing problem? Will we create a problem? So the next step is we then look on a street-by-street basis, and here's a couple of examples. At the top part, we had a landlocked area. We were going to have too much ponding with the inlet control devices. The water was basically going to be coming up close to the buildings. So we removed the inlet control devices in this ponding area, and we over-controlled elsewhere to keep the total flow the same in the sewer system. In the middle, we have a problem where we needed to regrade pathways between homes to make sure that we can get the water safely out to the street. Often you see the pathways are made with a little hump in the middle, but in reality, if we just made them flow right through, they're beautiful passageways to get the water through. So we started regrading a lot of them. And unfortunately, in the bottom, there's a street where the water's trying to make it to a ravine, but instead it turned down the street. And you know where water is always going to go, where somebody has a depressed driveway. That's always where it is. If you also notice, anybody who builds a depressed driveway, they seem to do it at the bottom of a street somewhere. So the outlet on that street was a depressed driveway. The driveway filled, the garage filled, the basement filled, all the water went there. So just by regrading the street and adding a speed bump, we were able to make sure the water bypassed that street. So we look at each street in detail when we do such an analysis. What did this mean? Well, in 2008 and 2009, we finished the work. In 2011, well, we got another event that hit. And the next event that hit, there were no reports of basement flooding. We had a few overland drainage issues. Some garden sheds got washed away. We had people were complaining about their gardens being damaged. I'll live with that. Quickly, the Sandy Hill control study that I was going to talk about. The Sandy Hill, what you can see in this picture here, is located in the old riverbed, probably from thousands of years ago along the Rita River. There's no outlet for storm system. So we had a combined area that homes that repeatedly flooded. So what we did in this particular area, we built a 12,000 cubic meter storage reservoir underground that would flood. Basically, that would with the surcharge from the combined trunk sewer, would flood this reservoir and protect the basements. Sandy Hill was also the lowest area where the park was. Where we were lucky is the lowest area in the bowl. And we had a lot of surface problem issues. This is near the university. You can imagine you have a foot of water on the street to 2 feet of water. The students get in their Jeeps, they love to drive through it. Water was hitting basement windows, breaking some windows, water was coming in. So now we created a pond over the tank. So as soon as the street floods, the pond fills. Here's the tank under construction. We have a picture of the park before and then the park after. The park is depressed by about 5 feet. It actually became a very beautiful feature in the neighborhood. There's now an outdoor amphitheater in the park, new play structures, wading pool. It really helped the community revive the park, which was pretty well like an old abandoned park not many people used, and now it's a really beautiful park in the community. It actually also won the American Public Works Association Project of the Year in 2010. So yes, this tank, since it was put in service in 2009, it's operated 8 times. Most of the time, it's only a few, I'd say, 100 cubic meters of sewage in it. But in 2009, the big event that hit the city, 10,000 cubic meters filled the tank. It has a 12,000 cubic meter capacity. Even worked so well that during construction, it filled. The contractor wasn't too happy, but the residents sure were. This shows you a street, new subdivision during a large event. This is what we're seeing. This is the new guidelines. I mean, this is what's happening on residential streets today. We have high intensification in a very flat area. So what are we doing to deal with that? Well, we're trying to look right now at the city of how to manage the flow in these flat areas, and we're actually finding we're trying to minimize the ponding depth on the street when you have rocking of your road. And we found that if we actually minimize the ponding depth and maximize the dynamic flow depth for the engineers out there, we're actually can convey more water and store more water in the dynamic portion. So we actually want to keep our total depth the same, but we want to make it dynamic. That's just one of the things we're changing in our guidelines. We also have temporary orifice controls at the where old subdivisions or new construction is meeting existing subdivisions to throttle the flow, so that we don't have contractors who accidentally open drain all their excavations through the existing laterals that are there. And so now it's going to be a throttled release rate at the junction, so that we don't flood the downstream neighborhoods. And we're doing a stress test. All designs, new designs, they have to increase the intensity, the IDF curve by 20%, so that we can see how the system is performing. It's not meant to design to that 20%. We want to see how robust the system is. We may lose our freeboard, but will it flood basements? If it doesn't flood basements, we're good. If we're noticing that with the 20% increase, it's really bad, then we're going to come back and tweak the design. I've talked quickly about the real-time control and storage tunnel. In yellow, you have what we call the central storage tunnel through the downtown core of Ottawa, which is currently under design. This is a large tunnel, which is really meant to reduce combined sewer overflow. So it would eliminate combined sewer overflows during a typical year in Ottawa. But the secondary benefit, it's an immediate outlet for surcharge combined sewers. So we're going to have now, when the combined system surcharges through the core, it'll immediately spill into the storage tunnel to then be bled back to the treatment plant. So we're just starting the design of that right now. So okay, I ran through quick. It's that. There were a lot of slides. So anybody have questions?
Thank you, Eric. We'll welcome questions now. I forgot to mention the first time. If you could please introduce yourself when you're asking the question, that'll help us all know where you're coming from, and who you are. So thank you. Yes, Kyle.
Kyle Chambers, City of London. Earlier on, you mentioned the sump pump retrofit stuff only being needed for an emergency. Are you saying there that you're connecting the foundation drains directly to storm sewers through gravity connection?
Yes.
Okay.
Yeah, gravity connection to the storm sewer, and then once it closes, then it would spill into a sump pit and be pumped out.
Is that backwater valve inside
the home?
Inside the home, so
yes.
they can see that.
While we're on backwater valves, I just want to quickly mention one thing too. The sanitary backwater, or the storm backwater valves, we had a flood in 2009 where a bunch of homes had backwater valves and they flooded. Why? Nobody checks if they're tightened, if the observation port is tightened. And hundreds of homes, the tops just popped right off and flooded basements. So we then went back into some existing, or not some homes, but some show homes. And we checked the backwater valves and they were all loose. The tops are loose. So it's something that homeowners need to be aware. They need to make sure that those observation ports are tightened.
Thanks. Can everyone hear the questions being asked okay? Is that fine in the back there? Are you hearing that? No? Can we have, if you can speak up when you're asking, that would be helpful. Thanks, go ahead.
Mike Dagan with the Cattaraugus Conservation Authority. One issue we find with the Conservation Authority is that when you're we're looking at designing streets to convey stormwater flows, major events. We're also using standards to control the maximum depth for safe egress and ingress. So those two things sort of conflict, where we use the standard 0.25 meters so that in a major flood event people can get in and out. But by the sounds of it, all this new subdivisions in the Ottawa area are being designed to be beyond that standard.
Yep. We designed 0.3 actually, and it was decided on an emergency vehicle that can come in and out, so police cars. But really our 0.3 is based at the edge of curb. Right now, what is being proposed by the consultant doing analysis for us is to go to 1.35 and maybe use the center line of curb. And the whole idea is that we can get so much storage in the dynamic portion of that when the water is flowing over top the sags. There's a lot of storage in that, and it could really help with the conveyance of major system flow. So we're studying that right now, but that's the direction we're heading in.
Yes, at the back.
My name is Keith. I'm Two Brothers Construction, actually from Ottawa. I do a lot of backwater valves in that west end area. Do you find that the flow restrictors that you guys install in the storm lines actually
If they're adequate?
yeah, they're adequate, they're doing what they're supposed to be doing?
So far, yes. We've, especially in the Orleans example I gave you, we've had another flood that was close to 100-year that hit in 2011. And a lot of people, many people do not install their backwater valves. Remember, this is a subsidy program. So the people, we don't force it onto people. They have to install it and we will pay them back. But not many people are taking it up. So in 2011, we had no report of basement flooding, and I would say less than 20% of the people there installed backwater valves.
Yes, please. Yes.
My name's Dan Franco from the city of Kingston, and I'm just worried about history repeating itself. So those older subdivisions were new at some point. Someone changed the lot grading, you're having problems. So are you guys looking at, a lot grading authorized by the city that you have to maintain it, or are you going to keep that as a private matter?
It depends. If it's a private home, the lot grading was designed, the stormwater management system is designed to take the flow from a home. If it's a private, right now if it's a commercial or a condo subdivision, we basically impose that they have to control the flow to a runoff coefficient of 0.5. We're improving. In a lot of places we don't know what the storm system is, how the storm system is behaving. We want to improve it. So if somebody's redeveloping, we're going to say control to the lesser of 0.5 or existing, and that to try to help improve the runoff.
So what I was getting at was alteration of a lot that exists where they have to do this and they fill it up in the garden and shed. Now you're actually blocking the swales.
Oh yes.
Are you going back into the lots and doing enforcement, or is that something else?
We're looking at that right now, but I don't think we've gone to that level of detail right now.
Yes, please.
Larry Thompson from Thompson Flow Investigations. Just wanted to confirm one thing. When you're implementing all these inlet controls, which can be very effective, are you also implementing enforced downflow disconnection? Because otherwise those are all uncontrolled inlets.
Yes, we can't go on. It's difficult to go onto private property and enforce it. We will work with the residents. We're going to inform them. We do go into neighborhoods that have flooded, and we will talk to people and say, you have this problem. You should really be disconnecting it. So, a bit of a touchy thing to come on and impose it onto private property. That's going to be probably another section in the weather infrastructure management plan. There's a section on bylaws. Stay tuned. It'll be fun how council deals with that one.
Thank you for the good questions. We'll take one or two more.
Great. Brian Wilson, Center for Data Technology in Chicago. Eric, I'm really interested in how you actually get information from residents who are experiencing basement flooding or flooding, and what level of detail are you collecting?
We have a call center, and as soon as somebody floods, we send somebody to their home. We'll try to do it as soon as possible. Sometimes it may take a couple of days. That inspector will inspect where the water came in from. We'll talk to the resident. We'll take information. That information is critical. It's very critical because we want to know how the water came into the house, because it's going to give us an indication if it's storm or sanitary surcharge. And so far we've been getting a lot of good information from our first response team.
And so the call centers, what information do they collect?
Right now, they'll just collect the fact that somebody flooded, and they'll just dispatch a team there. The call center is just to take note of the address and the day and the time, and a team will be discharged to inspect.
Our work shows that the far more people call for sure and will call the cities. So by an order of 5, 6, or 7
Do we have a final question, or shall we break for coffee? Glenn, go ahead.
Plumbing Drug ICLR. You now require backwater valves, 2 backwater valves on new construction, storm and sanitaries. Was there any pushback from the building for this?
No, so far we really haven't seen pushback. I mean, the backwater valve is not a very expensive item, and it goes into the basement, and we haven't heard anything. And we're on all new development in existing areas, in the partially separated areas. We're definitely imposing. If anybody who's reconstructing a house or renovating or something, we want to see a backwater valve go in.
Okay, well, I'd like to thank Eric for his presentation, and thank you for your questions and the lively discussion. We'll take 15 minutes for a coffee break right now, so I'll call you back shortly, and stretch your legs and feel free to grab a snack or coffee. Thank you.